At this time, Dr. Chris Graney.
So to re-emphasize what Father Salpe said, figure out where you're going to be. I'm going to actually go up on the hill a bit because I want to sort of see what the shadow does on the ground as it's approaching. But you do not want to be standing just atop that retaining wall or something where you're like, oh, wow, 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 and down you go. So there's something a little rough about the projector. We'll see how this holds up. Okay, so this is my second talk. First talk was no PowerPoint, kind of informal. Tried to get a lot of discussion. And I've been trying to get from people what they know about, what they're concerned about, what they have interest in. And so this time we got the PowerPoint. We got a lot of stuff. Okay, but this is based somewhat on the feedback that I've gotten from you guys. To start, I just thought this was interesting. My wife pointed this out as we were driving to find a hiking trail. And this is just up the road. Whitehall Holiness Church. Tomorrow's forecast, God reigns, the sun shines. And on the back side of it is the heavens declare the glory of God. So I thought that was fitting. Very cool. Yeah, it's not just us that's out here doing this. Okay, so this is the thing that I picked up. More Galileo, okay. Did Galileo's discoveries support Copernicus's hypothesis of a heliocentric universe, okay? So I'm gonna pick on all my fellow speakers to some extent, not all, several, but I've picked on Father Salpe before about mentioning Galileo. And then Dr. Cookie, he had Galileo's discoveries and supporting the heliocentric system in one of his slides. And I'm like, oh God, And then I'm outside in the dark and I get into a discussion with Dr. Fry about phases of the moon, phases of Venus and heliocentrism. And I'm like, why is it that I'm hearing from, people who are using, they turned the Webb Space Telescope around for Dr. Fry, right? Dr. Cookie's using the Keck telescope, right? It's like tonight or tomorrow or something like that. Biggest telescope in the world. Why am I hearing this? And that's because, all right, so the answer to this question is no. But this is what we're taught in our astronomy books, okay? This is what I have taught my students. Go go all over the place. You see this. So, how am I going to persuade you all of this? And the answer is, I'm not. I'm going to let somebody else do it, okay? So this is from a book around the time of Galileo, 1614, that illustrates what the telescope shows. Here is the moon. Galileo saw features on the moon. Galileo saw the phases of Venus, that it goes through crescent to full phase. All 4 phases of Venus, right? It goes through all these. It proves that Venus circles the sun. Jupiter. You all, those of you who were out with the telescope, you saw the moons of Jupiter, okay? You saw these diagrams of moons of Jupiter observed in 1612, 1613, 1614. The Jovian system, this is light from the sun. Here's the planet Jupiter, the shadow of Jupiter cast out there. The orbits of the 4 moons, their entry points and exit points into the shadow and out of the shadow, crossing in front of the disk of Jupiter and behind and out of the disk of Jupiter. Too far. Sunspots. Some of you all were looking through telescopes early and saw sunspots. When you're looking, there's a big sunspot on the sun, or at least there was yesterday. Probably when you're looking at the eclipse, you're going to see sunspots today. Okay, this is sunspots. But this book isn't from Galileo, right? This book is from Team J again, okay? This is Christoph Scheiner's and Johann Georg Locher's mathematical disquisitions concerning astronomical novelties and controversies. This is a a Jesuit astronomer and his graduate, sort of basically graduate student. Shiner would go on to become the first person to do an in-depth study of an astronomical object, not simply like, oh, look, we see this, we look at it for a period of time, we move on to something else, but years long study. He studied the sun, okay, how sunspots form and move. This is part of the apparatus that he built, he and his students. Telescope, you're seeing them projecting onto a screen to observe the sun. Shiner did not, so it's Shiner who and his student Locher who are reporting those discoveries. All right, that's not Galileo. But Shiner does not believe that they show that the Earth goes around the sun. Okay? Shiner subscribes to this model of the universe, in which the Earth is at the center, the sun goes around the Earth, and so does the moon, and so do the stars, and the planets are essentially moons of the sun going around the sun. This is called the Tychonic system. This is the system you don't hear about. You hear about the old, totally Earth-centered universe. You hear about Copernicus. You don't hear about this. Okay? So look at this. Keeping in mind, Tychonic. Sun goes around Earth, planets go around the sun. So I showed you this diagram. Okay? Shiner has this really interesting research proposal in his book in which he says, if you time the motions of the moon in and out of the shadow and across the disk, you can work out the angles in the solar system and you can calculate the geometry of the solar system and the distance to planets. What's this? It's the sun. Okay? What's this? It's the Earth. What's the sun doing? Orbiting the Earth. Okay. Shiner thinks that it believes that the universe is geocentric, even while accepting all of these telescopic discoveries. Okay. Why? Because, so here's heliocentrism, here's Tychonic geocentrism. Tycho was the most prominent astronomer of his age. Okay. There's a number of things, I'm not going to go into the details about that. With the heliocentric system, there was problems with the sizes of stars. There's problems with this thing called parallax. There is no physics to explain how the Earth would move, as opposed to the established physics of Aristotle, which still worked under this system. There was no problem with what we call the Coriolis effect. Yes, these Jesuit astronomers figured out that if the Earth was rotating, there should be this thing called, that we now call today, the Coriolis effect. They couldn't detect it. So it's like, look, the Earth's not rotating. Okay, and of course, there's not a problem with the scriptural stuff either. That's a diagram from Giovanni Battista Riccioli about the effect that a rotating Earth should have on the path of a projectile, right, which we now call the Coriolis effect. Nevertheless, okay, I've just shown you these Jesuit astronomers and all the stuff that they looked at regarding the discoveries through a telescope and stuff like that. Nevertheless, not that long ago, as I mentioned in my last talk, there was this article about showing that a document at the University of Michigan that was once thought to be the writing of Galileo actually turns out to be a fake, a forgery. But in it, very close, right where it's arrowed, the second paragraph says, Galileo Galilei was peering through a new telescope in 1610 when he noticed something strange, the moons orbiting Jupiter. The finding, which was condemned by the Catholic Church, helped prove the theory of the sun-centered solar system. Okay? It wasn't condemned by the Church. These scientists were busy confirming it, elaborating on it, building on it. And it didn't prove the sun-centered system because all of those discoveries were completely compatible with the Tychonic theory. Things circled other things in the Tychonic theory. Venus went around the sun in the Tychonic theory. Johannes Kepler said there's no thing you can do with a telescope looking at the sun, moon, planets to distinguish between these two theories because they're identical. The only thing you could look at was the stars. All right. Or find a Earth-based thing like the Coriolis effect that showed the Earth's rotation, which no one could do. So in trying to put this together, to add insult to injury, I looked and I wrote a thing for the Vatican Observatory's blog about this poem that Pope Urban VIII wrote. And I was like, rather than just hunt that down, I'll find the post I wrote and I'm going to snag images from it. So I throw in Pope Urban, Moons, Jupiter, Galileo, and this is what comes up. Thank you, Google, for the dagger through the heart, right? The Galileo affair. The Pope refusing to look through Galileo's telescope at the moons of Jupiter is an icon of humanism. The Pope declined to view evidence that not everything in the universe revolves around the Earth. Okay. To the contrary. Here is a book of Pope Urban VIII's poems. I hate trying to read Latin aloud, especially among church people, might be better pronouncing Latin. All right. But we have here, miratu alter vel Jovis seclas, patrice Saturnae repertos docte tuo Galilei vitro. Okay. Still another person marvels at the heart of the scorpion, or at the blazing dog store, or at the attendants of Jupiter or of Saturn, his followers, that were discovered by your glass, learned Galileo. This is what the Pope who refused to look through the telescope wrote. Okay. Okay. The attendants of Jupiter, Saturn, it turns out those are his Saturn's rings that he's talking about. So he is mentioning Jupiter's moons, Saturn's rings. This is clearly not a person who refuses to look through the telescope. Exterior radiance does not always mean interior brilliance. Consider the dark blemishes on the sun. Who would have believed it? Revealed by your craft, Galileo, right? Quis credat? Who would have believed? In sole respicimus nigris, in sole quis credat, etc. Okay. So, Galileo's discoveries did not prove or help prove the heliocentric system. Okay. Then why are they important? Okay. Because they demanded change. All right. They didn't prove heliocentrism. They proved that old ideas were wrong. The old ideas of Ptolemy and stuff were wrong. Okay. The old was out. Galileo's telescopic discoveries showed that. But something new was coming. What was it? They didn't know. Okay. But contrary to the idea, like, oh, we're not going to look, we're not going to understand. Here's Christopher Clavius, which other guy had this picture up in one of his slides. A very prominent Jesuit astronomer who died not too long after the telescope was invented. But in one of his last works, he had this astronomy book that he wrote that was a commentary on the sphere of Sacrobosco. The sphere was this long-standing textbook that was written in like the 1200s. And Clavius says, not long ago, a certain instrument was brought from Belgium. It has the form of a long tube, in the bases of which are set two glasses, or rather lenses. And then he goes through all the discoveries. This instrument shows many more stars than can be seen in any way without it. It shows the moon appears to be so remarkably fractured and rough that I cannot marvel enough. Venus, sometimes it appears to be more like a crescent, sometimes less. Jupiter has 4 roving stars which vary their places in a remarkable way, both among themselves and with respect to Jupiter, as Galileo Galilei carefully and accurately describes. Since things are thus, astronomers ought to consider how the universe might be structured in order to explain these phenomena. Something new is coming. But Clavius and most of Team J, right? For those, if you've not been here before, there's been a lot of comments about Team Jesuit, okay? Because there's a lot of, Team J is Team Jesuit. Right? A lot of Jesuit astronomers in these time periods. They like this one, Tycho Brahe's system, for scientifically sound reasons. And I would argue that as they were the scientific consultants of the church at the time, then what Team J likes is what the suits are going to like. Okay, you know, the suits, the boss man, the suits. And that, namely the Pope, the cardinals, you know, the people in charge. Because they're not astronomical experts. They're going to go to the astronomical experts and say, well, what do you think? And astronomical experts are Team J, and Team J is going to say this. Okay. And the case for it is extremely strong. So, if you weren't here for my first time around, I mentioned that the questions of religion and science date back to at least St. Augustine and the question of the two great lights and the sizes of the stars. And Augustine here, and then also Aquinas, and getting out of the Catholic Church, later John Calvin, all said, look, if the argument is solid that the stars are actually bigger than the moon, then we simply interpret Genesis as saying the business about the two great lights is what we see with our eyes. Okay. So we got this covered. So, did Galileo's discoveries support Copernicus's hypothesis of a heliocentric universe? No, at least not over Tycho Brahe's. Remember this. And now, I'm going to give some gifts to these people that I've been picking on. Right? And what I'm going to give them is a copy of Shiner's book and Brother Guy and I's paper about the Jesuits and the Coriolis effect. So, let's see, Dr. Make sure I got it right.
He was a professor for 30 years. He gives homework.
How much we have to read of that?
Where's Father Salpe? I'm not. Okay. I got Father Salpe.
Probably changing costume.
And because I don't want to, I haven't picked on Father James, but I don't want him left out, so I'm giving him a
thanks.
And if you think I'm leaving out Brother Guy, I helped him make a solar filter for his phone. So, all right. I don't know how you solve this problem of that. Because I'm sure that Google thing, it was really bothersome, and I'm sure that's some AI thing that like finds something, spits something up. I've done a little work on AI and history of astronomy, and the AI stuff spits out the same stuff that's on the rest of the internet, which is wrong. So, and I don't know how you fix this, but maybe, you know, you guys, if you're, you know, you're talking to somebody, you know, the media is, I contacted the New York Times about that article. And I talked to the author, and exchanged some email. He wasn't persuaded, all right? But maybe, you know, if you're talking about the keck or the web, maybe somebody will listen to you, right? So, read what, okay, so now to continue, I like Team, Augustine here, he likes Team J, right? We all like Team J. But we have more than just Team J. Okay, and that's what the rest of what I want to talk about is. All right, so I'm going to talk about something a little more local. I'm going to talk about the oldest telescope in Kentucky. All right, I will say the oldest, by a telescope, I don't mean a spyglass used by like a cavalry officer. I mean an astronomical telescope, because there is a spyglass in a museum that's older than this in Kentucky. This is in the archives of the Archdiocese of Louisville. At least a couple of people here have seen these slides before, because we gave several talks about on this. This telescope was owned by Monsignor Michael Boucher, who was a priest who became the rector of the cathedral. I think he became the vicar general of the diocese as well, in the late 19th century. And this telescope sat in the archives for more than a century, right? We have a little diocesan museum History Museum. So I always think it's cool to show astronomical equipment along with monstrances and stuff like that. You know, I think that's nice. But the telescope and its box have been in the archives. It was sitting up on a wall, and somewhere along the line, oops, I should mention, there's Monsignor Michael Boucher. It looks like a really amiable guy. He's pastor, vicar general. He was also an inventor and a patent holder on various patents. This is an adding machine that he invented. Our archivist says there's one of his things that's in the Smithsonian. There's his signature on the inside of the box that the telescope was in, along with some instructions on where it's supposed to go when we don't know where that was. The mount for it is gone. It's probably in the attic down there with the Sisters of Charity of Nazareth somewhere, because we think that this is the academy. We have reason to believe that he had connections with Nazareth, so it could be in some attic down that way. It was built in Louisville. You can see, made by A.C. Schumann, Louisville, Kentucky. So it's not only owned by a local person, but built by a different person. And the two of them apparently worked together on different things, inventions. Schumann was a manufacturer of mathematical, optical, and philosophical instruments, engineers, instruments repaired, etc., etc. Northeast corner of 4th and Jefferson Street, which is just around the corner from the cathedral, which is on 5th Street in Louisville. And this is a patent for a clock striking mechanism. So Schumann was also an inventor. These are the other things made by Schumann that I found: a compass, a microscope, this is advertisement for him. It was in some magazine or something. Models for new inventions made and developed. Well, through a happy turn of events, I got the opportunity in talking with our archivist, to try to restore this telescope to order, to use. Okay. Now, happily, I got help. Advice, not physical help. This guy is Paolo del Santo of the Museo Galileo in Florence, Italy. And that's him working on one of the original remaining Galileo telescopes. Okay, or at least what we think is a telescope that Galileo actually built. There's reason to believe it. There's actually some slight holes in the provenance, but they're pretty sure it's Galileo's telescope. So he helped out with commentary. He got interested. On the internet, I had posted, we're doing this, and he started offering some advice on what not to screw up. One of the interesting things is he said, Americans, he said, you restore something and you polish it and rebuild it and so on and so forth until it doesn't look like an old thing. It looks like a new-made replica of the other thing, he said. Now, he said, we Italians, we love old things so much that we just let them look older and older until they fall apart. You know. So, but this is Tim Tomes, when I first started working with him, who's the archivist. And this is the event that actually prompted the work to start on refurbishing the telescope. This is the induction of our Archbishop, Archbishop Fobb, Shelton Fobb. There was a mass before, there's a name for this, which is escaping me at the moment. But installation. Thank you, installation. He comes with a mallet and boom, 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 bangs on the door, and they open the door and they let him in. And so, and then he said, Tomes, the archivist, was serving Mass. Tomes is a big guy. He's like significantly taller than me. And I hadn't talked and thought about the telescope in quite a while. And he was dressed in altar garb and comes walking over and says, "Hey, Chris." And at first I'm like, when you don't see people in familiar settings and you haven't seen them for a while, you're like, what? Oh, it's Tim Thompson. And they said, we need to do something with that telescope. And that prompted action. So, telescope gets disassembled, cleaned out. It's really not in bad shape. The biggest problems are just gunk, okay, and stuck screws. What really stinks is trying to undo a pure brass screw that's been in place for over 100 years that's stuck. Because if you put a screwdriver into a brass screw, a steel screwdriver, and you turn it, if you try hard, it's like putting a knife into butter and turning it. Brass is not that tough. And so it was the WD-40, put the screwdriver in, turn it lightly, tap gently on top of it, vibrate a little bit. It took there's the screws that hold the eyepiece, the tailpiece into the end. There's 6 of them, 5 of them. 3 of them came out pretty easily. 1 of them took about half an hour to get loose. The other one took over 2 hours of slight, gentle torque, tap, tap, tap. A little bit of WD-40 with a Q-tip, tap, tap, tap. Got it out, didn't damage the screws. So this is it disassembled. That's the focusing mechanism over there. It's just not real well designed. I'll talk about that in a minute. So the focusing mechanism, the biggest problem was this focusing mechanism is internal to the telescope. It's got a gear on a shaft that then engages with this rack gear along here. And the problem is it would bounce out of so if you put force on it, it would hop. There's flexibility. Because the thing that was designed to hold it had either wasn't that good in the first place or deteriorated. And a big breakthrough was that my wife, who always hates for me to point her out, at this point, we used some wool. Why wool? Why? You don't want to use some sort of synthetic fiber because we're building something that hopefully will last another 100 years. Some sort of synthetic fiber might outgas and deteriorate, and then where is that stuff going to go? It's going to coat the lenses on each end of the telescope. So it's got to be something that's going to be stable. So wool, and then put this on here, and that served as a bushing to hold the gear in place, solve the focus problem. Yay, Tina. So there it is. You can see here's the gear, goes in there. Then that's it stuck into the focus end with the wool that holds it in place. I'm not going to try with an internet connection, but this is the focusing mechanism. Turn the knob, this goes in and out. Eyepiece, it needs work. So worked on that, got it back together. Mount. Okay, there is no mount. So what to do? Buy a new mount. Okay. Well, it's a pretty big telescope, so a new mount will be somewhat pricey. And the other thing is it's like, really, does a computer-controlled mount look right with this 120, 130-year-old telescope? Maybe not. Well, you could buy like an old mount and refurbish it, or there are even like replica mounts. These are hard to find. It's going to be a lot of work to refurbish it, and they're going to be really expensive because they're rare. These are also really expensive, and the problem is are they really actually replicas made to use, or are they just art objects? As the phrase goes, the Lord will provide. I was at a meeting of the Louisville Astronomical Society, and over in the corner, they have this stack of junk telescopes that people have given them. They're bad telescopes that they sort of scavenge for parts. And they had this thing that they call a Bird-Jones telescope, which is never mind. It's a telescope that's not the best design. But it has this lovely looking wood tripod, okay? It's like, now this isn't the same age, it's like 50 years old. But it's something that Monsignor Boucher would recognize. Took some work. Okay, that's just testing it out. I got a lot of rags and stuff stuck on there and bungee cords to hold it. But in time, I added a longer shaft because I needed to reduce the counterweighting on the telescope because it was kind of at the limit of what the mount could hold. And then that person who's good at making things out of wool figured out how to work bushings so that the telescope would hold, and yet even if this thing was on display for years, they wouldn't like gum up, because they're made out of synthetic material. And so we end up with a functioning Monseigneur Boucher telescope, and there it is in the library room of the History Center. These are all these books. A lot of them go back all the way to the first. So the first diocese in the United States. Okay, so not talking about like in Spanish Florida or stuff like that, but in the country called the United States was the Diocese of Baltimore, and that's like 1780 something. And then in like 1805, they split off diocese out of the Diocese of Baltimore. There's the Diocese of New York, Boston, New York, Philadelphia, and Bardstown, Kentucky. Okay, and that's because a bunch of Catholic settlers had come over and settled in Kentucky. So this whole very heavily Catholic area in Kentucky that's called the Holy Land, where there's all these churches that were built in like 1785 and 1815 and stuff like that. And the Dominicans. The Dominicans' first Dominican house in the United States is in the Diocese of Bardstown, in a place called Springfield, which is kind of like it kind of looks like this, right? It's nowhere, hills, pretty. Okay. And anyhow, a lot of these books go from the first bishops that were there, most of who came from France. I was testing it out on that tower. I got video, but I'm not going to go there. I'm not going to try that. So, among my duties with the VO is I am it's called an adjunct scholar with the VO, so I do research and stuff like that, and because of that I need to make contributions to our annual report, but I also serve as the editor of the whole annual report, which probably makes me and Brother Guy the only two people to read every last word in the annual report. Right. Oh, and my wife, right, who now wants to be recognized. That's right. That's part of why I'm chosen as the editor, because I have a backup who helps me edit. Tina does many of the reasons why I've been able to do things is because I have someone who is really good at helping at lots of stuff. All right. If you can, I recommend you search for Vatican Observatory Annual Report on the internet and download it and look at it, because it's really cool. And I don't just say that because I edited it. Okay, this guy Antonio Coretti does the layout. He's in Rome.
His birthday is today.
And his birthday is today. So, in the unlikely event that Antonio Coretti is watching this live stream, happy birthday, Antonio. Download it and check it out. It will really tell you about what goes on at the Vatican Observatory. The wide range of research, from cosmology, studying like new mathematical approaches to working out Einstein's theory and of gravity and the Big Bang, to historical stuff like me, to the gazillions of talks that Brother Guy gives all over the place, to what other kind of things? Books that people publish. Father Michael Heller, who's like, what now, 87 maybe? There's a new Pope, St. John Paul II. And he's been a part of the observatory, an adjunct scholar like me for a really long time. So anyhow, but I had to make my own contribution because that's part of the job. And so Brother Guy always says, hey, we need pictures. So I sent pictures. So we took, after we got the telescope done, Tim and I took it around the diocese. We took it to Bellarmine University. Bellarmine University grad there, right? Okay, any other Bellarmine University people? Another Bellarmine University, okay. We took it to Bellarmine. That's at Bellarmine. So that's students, faculty, and some community members. We took it to the place where Father Boucher was, one of his first churches he was stationed at, is this place called St. Gregory Church in Samuels, Kentucky. Samuels is usually, if you've heard of Samuels, it's because there's a big distillery there that says Samuels on it. So you may, that's there. Okay, this is testing out. That's Tina. We're testing out. This is first light for the telescope, or first light for the refurbished telescope. We're looking at Venus there, I think, and that's the archivist Tim Tomes, and he looked at this. He was all excited. Oh, we're in a Vatican document. He's like, and I'm wearing shorts. So. This is a gold mass. We have a gold mass for science. The Archdiocese has a faith and science discussion group. It's connected with the Society for Catholic Scientists. If you recognize this that's the Archbishop. If you recognize this person, that's Holly. Where's Holly? No, there's Holly. That's Holly. So, and I just want to point that it was just really cool for people. You had this interesting intermix when people came to look to use this telescope. The performance of the telescope is not fantastic. It's the eyepieces are clearly sort of homemade, and the tailpiece actually got engraving from a manufacturer in England, and it's clear that they used the tailpiece of a different telescope to make the focusing mechanism, and the eyepiece, I thought about we could replace this eyepiece with a modern eyepiece and the view would be much better. But, we can have a modern telescope for someone to look through. This shows like Father Boucher would see through it. And it's pretty good. It's not super, but it's good enough. It's good enough, especially the moon. You can see the moons of Jupiter. You can see craters. It's good. But so you have people and they're looking, and you have people, it's this wonderful intersection for people with interest in history, okay, they're interested because it's a historical thing. People with interest in religion because, it's a church thing. And people with interest in science. So you have history, science, and religion all intertwined here. And if there's not something in that interests you, then I'm sorry, that's, and it's just a really, really cool, and we're going to take this out. Then it started getting cold, and now we're going to probably take it out to some more churches within the diocese. Just like you guys who are here, what we have found, that gold mass, Holly here, we had 200 people show up for the gold mass. Okay. Now we've done 3 gold masses, and they haven't all been like that. One, about 100 people showed up. One, about 30 people showed up, and this one, about 200 people showed up. We don't know what drives that. But the point is just like you all here, we see that within the church there is interest in science and the church's role in science and history. And I just want to put a contrast, this versus this, okay? What we hear versus what is in the historical record too, okay? And so I will stop here with remind that St. Augustine was unbothered by scientific discoveries that contradicted the literal words of Scripture. Had a simple way, okay, yeah, stars are bigger than the moon, but the moon is bigger to our eyes, and that's what Genesis is talking about. Or as John Calvin said, astronomy is great. I love astronomy. We ought to pay attention to what astronomers are doing. It's really good that they have time to work on this stuff that other people can't do. Don't get bent out of shape about the fact that this contradicts the Bible, because the Bible is not made to haul us up into heaven and show us the actual sizes of the moon and stars. So thanks. I'll give questions, but first I'm going to go give Father Sape his book. I was hoping if I talked fast enough, we'd have time for questions, so we do. Yes?
Could you give us a little definition? You were referring to the Coriolis effect.
Coriolis effect? The Coriolis effect is essentially what's responsible for hurricanes. If the Earth was not turning, we wouldn't have hurricanes. Okay? At least not like we have them now. I don't think, we probably couldn't have any kind of storms without a rotating Earth, would we? Maybe.
Venus is a planet without rotation, and it's got weather, but it looks really different.
Yeah. So when you're here, like, I think north is that way. Okay, the Earth is at the pole. If the Earth is turning, then at the poles there's no motion, right? At the poles, the Earth is just. If you're on the North Pole, you'd just be doing this. At the equator, the Earth is 24,000 miles around, and you go around 25,000 miles around, and you go around once every 24 hours. So at the equator, you're going over 1,000 miles an hour. So if you imagine you're at the equator, so you're on the North Pole and I'm on the equator, I'm going to throw a baseball to you. Okay, we can just imagine that was possible. Then I throw you the ball. Well, I'm going east at 1,000 miles an hour. So the ball is heading north up toward you. But the ground, if you're 1,000 miles an hour at the equator, 0 at the poles, that means the ground is moving progressively slower as you go, which means the ball, which is moving at 1,000 miles an hour to the east, because that's what I was doing, is now going to start outrunning the ground. And so you're going to expect to have a deflection of the... And this is Shiner and Locher have the first... Galileo recognized this to some extent. Shiner and Locher have a discussion of this. Father Giovanni Battista Riccioli, another Team J, okay, talks about this. And then the person who really nails it down, Riccioli's discussion is lengthy and convoluted. I mean, it's right, but it's not something that a lot of people are going to want to read and understand. But Father, I'm trying to remember what his, Claude Baptiste Millet de Chales, in the later part of the 17th century, gives diagrams that you could put into a textbook of today, of this. And the whole point is, if whether you're dropping a ball or throwing a ball or something, the Earth's rotation, if the Earth is rotating, then there should be deflection of these trajectories. If the Earth, and it should depend on it should vary with where you are on the Earth. Whereas if the Earth is sitting still, every place on the Earth is dynamically the same. You shouldn't see any change. Actually, Tycho Brahe brings this up, too. And so it's we don't see this effect. Therefore, that's, the Earth is not moving. Now, it turns out the effect is a lot harder to detect than they would ever guess. When you move something through the atmosphere with any speed, it creates this stuff called turbulence, which creates this stuff called chaos. So if you try to drop balls from high places, they do all kinds of crazy things. So there's experiments where with trying, this was long after it was known that the Earth rotated, but there was we ought to be able to detect this effect. Dropping balls on this immensely deep mine shaft in England. They let the balls go at the top with some mechanism designed to release them with great precision, and they never get to the bottom. Well, how could that be? Well, it's because the turbulence kicks in, the balls start doing all kinds of crazy things, plus they're going at high speed, they probably just buried themselves into the wall of the mine shaft somewhere along the line. But it turns out to be way harder to detect than you would ever guess.
In this era of big astronomy, are there still places where amateur astronomers can contribute to astronomical knowledge?
Yeah, I think so. I mean, for a couple of reasons. One is that the equipment that amateur astronomers have access to now itself is growing more and more powerful. The limit is simply what your telescope and things like that. And that's not. I'm trying. I know there are examples of amateurs having contributed recently. Guy, do you know of one that's escaping me though at this moment?
First of all, with all respect to the James Webb Telescope and the Hubble Telescope, one of the brilliant things that they did, besides building a fabulous telescope, was to devote, I think it's 5% of their budget to PR. So whenever you see a pretty picture, everyone, that must be Hubble. It's not Hubble. It was probably something taken on Earth. There are lots of wonderful telescopes on Earth, small and big. One of the problems with big telescopes is that by design, they look at a very tiny piece of space. Working with us at the Vatican Observatory is a fellow who did his postdoc at the University of Michigan, Richard D'Souza, who's interested in how galaxies accrete and how galaxies collide To be able to see that, you need to have a field of view that includes a galaxy and stuff around it. And those best images are actually done by amateurs. Another place where amateurs have a huge effect is in looking at observing asteroids, especially light curves of asteroids. An asteroid is a point of light, but you can see the point of light get bigger and smaller and bigger and smaller. That tells you that it's spinning. How much it gets bigger and smaller tells you the size of it. And if you can see that from different points in its orbit, then you have more than one measurement of big and small, and you can actually come up with a shape model. And all of those data are collected by amateurs and then put together by, a professional. So there is this tremendous, these are just a couple of examples of a tremendous collaboration between amateurs and professionals. Goes on all the time. And I can see people here want to jump up and tell us other cool stories. So start in the back.
So one thing that's actually happening today, probably, maybe even at this moment, no, not quite yet, but during the eclipse, there are actually going to be amateur photographers across the country photographing and videoing the eclipse as it happens at each spot, right? I think it's like 150 at least across the country who are all then going to send that data to NASA so that they can study the sun's corona. So yeah, like literally today that is happening.
And for the people live streaming, if you didn't pick it up, there's a network of amateur photographers taking photos of the eclipse across the country for studying the sun's corona in detail. So, yes?
I'll just add really quick, and probably easier.
Okay.
Thanks. So an area that amateur astronomers have contributed greatly to is the area of supernovae and transients. So supernovae are stars that explode and die. They happen unpredictably. You've got to scan the whole sky looking for them. Like Brother Guy said, those big telescopes look at a little area, so you're not catching things. So most of the supernovae early on in history were discovered by amateurs, and amateurs' telescopes, as they said, and equipment are so much better now, professional grade essentially in many cases. And a program that I have, which I coordinate lots of telescopes around the world, I actually have some amateurs involved in it as well. So you're monitoring things that change over time, but you can't watch them all the time, everywhere all the time. But if you have other people doing that, it contributes greatly to understand how they evolve, what they are, etc.
Yeah, you can. Father Salpeo, you telling me I need to quit?
Comets.
What?
Comets.
Comets, yeah.
Amateurs are getting comets all the time.
That's right, amateurs are discovering comets. And for the price of a nice car, a person can go out and buy a 16 or 20-inch telescope, camera equipment and stuff that most professional astronomers through most of history up until, I don't know, the 70s or something would have think like, oh my gosh, yes.
That's right, yeah, just to follow on to Jeff Cookie's idea was that also a handful of years ago, there's the very, very enigmatic object called the gamma ray burst, which exploded. It's not even obvious exactly what the progenitors are of these, but it was a gigantic burst that went off about 7 billion years ago, very distant, and yet you could see it with your naked eye. If you knew where to look. So a small telescope network can also greatly contribute to that type of transit in solving a real outstanding mystery in astronomy. So small telescopes can play a big role.
So I think we're gonna have to wind it off. Well, okay, let's see if we can make it quick, because you were
curious. There's supposed to be a bunch of aircraft today. Instead, you may mention of what's going on from the surface on the ground. But I understand there's a lot of aircraft that are going to be photographing, and I don't know, I can't imagine how close they're going to be getting to anything.
Oh, it's not to get close. Maybe get above the Earth's atmosphere a little bit. A little bit of the thicker part of the Earth's atmosphere. But the thing is, if you're in an airplane, you can actually be following the moon's shadow across the ground, and so that stretches out the length of time too. So I think we've got photos and stuff, and I'm going to call off. But I hope. So some of the questions, there was a discussion about some movie and things like that. I don't know how you solve the problem of like how things are represented about the church and science versus the reality. But what I can tell is that is I think it is useful for you all. You may not be able to persuade anybody, but at least you yourself, I hope that you understand that this story that exists is not accurate, and you shouldn't be thinking, oh, gee, that we did such a bad thing with science. That's not, we didn't necessarily, the church hasn't always treated people well. Okay, Galileo is not treated well. Lots of people are not treated well. But the idea of like, oh, I refuse to look at a telescope, I refuse to accept science, yada, yada, yada. Bogus. So.
Let's give a nice hand. We're going to assemble up here.